We're going to continue our study of sequences by talking about what happens when we add those numbers together. Now, a sequence is just a list of numbers. A series is the sum of a sequence. An arithmetic series is the sum of an arithmetic sequence. And then a geometric series is the sum of a geometric sequence. Now we can show the sum of a sequence through this notation. We use the Greek letter sigma. This is the capital for an S. And a sequence always begins, we count our terms, T1, T2, T3. So we count those terms beginning with 1. And what goes in the sigma is we're adding each term. So this would be the same as the first term plus the second term. And then we would end at a certain point, and I'm just going to give that number a letter. We're going to say a K. But you start here, start counting here, and then you end here. The Tn, we find our equation for the nth term, and that goes there. Now, we're going to write the series in expanded form, and expanded form means don't add. So we don't want the final sum. What you're going to do is substitute one at a time. We're going to begin with substituting, then the variable here you're going to notice is not an n, it's a k. It doesn't matter what the variable is as long as they match here and here. So what this is telling me is to begin with k equal 1. Here's my first number. And then we're going to substitute in 2. And then we're going to substitute in 3. And we're going to continue doing this until we reach 5. And the reason we stop at 5 is at the top of my sigma is a 5. Now the reason I'm writing it like this with all of these parentheses is that I want to know what the first term is. This is T1. And so I'm going to figure out, and this ends up being 4. This is 7. The third one is 10. Fourth one is 13. And the fifth one is 16. And as you can see, this is an arithmetic sequence. 4, 7, 10, 13, 16 has a difference of 1 with the first term equal 4. And if you add those 5 numbers together, that would be our final answer, but I want my answer in expanded form, so this is the answer. Now let's try this again. We're going to begin counting with 1. We're going to end with 4. And again, it does not matter what the variable is as long as this one and the variable inside the expression match. So we're going to substitute one at a time, beginning with n equals 1. So 8 minus 3 plus 8 minus 3 times 2, so that's 6. 8 minus 9. 8 minus 12, and then we end because it only asks for 4 terms. So we have 5 plus 2 minus 1 minus 4. And as you can see again, this is an arithmetic series. It has a common difference of -3, and this would be our answer. Now, what we can do is go backwards. Now, here's the first term, second term, third term. We don't know which term this is. So we need to find, first of all, we need to find the equation for the nth term. And then the second thing we need to do is find n for Tn equals 100. We need to find which term 100 is. So let's start with finding our nth term. Now our nth term formula, if you remember, is the first term plus the difference times n minus 1. We know the first term, that's 10. And we know the difference is 5. So we can substitute in for that. So Tn equals 10. Well, actually, no, that's fine. Difference is 5, so n minus 1. We're looking for the general formula. So 10 plus 5n minus 5, that is 5n plus 5. Alright, so we'll write our sigma down here at the bottom. We're going to start with 1, and we're going to add the terms of the arithmetic series, 5n plus 5. But we need to know what the n is for 100. So I'm going to substitute 100 in for Tn. And I'm just going to use 5n plus 5, and we're going to substitute in and solve for n. And n is 19, and that is our ending point. So this is the number that's going to go on top of sigma. So it tells me if we add the first 19 terms, we'll have those 19 numbers. Alright, now I have a series. It is also arithmetic, and I want to replace 1 and 2 with fractions that have a 3 as a denominator. So 1 is 3 over 3, and 2 is 6 over 3. Now what you could see is that you're counting in the numerator from 1 to 6. So n, you have 6 terms. If we use our nth term formula, we begin with 1/3, and then our common difference is also 1/3, n minus 1, and we have 1/3 plus 1/3 n minus 1/3. Well, these 1/3s cancel, and we'll just have n over 3, or 1/3 n, for our Tn. And we have 6 terms, so we know where we're stopping. So our sigma, we start at 1, end at 6, and the nth term formula is n over 3. Okay, now let's look at this series. I have alternating signs, so this is geometric, which means I'm dealing with a ratio, which is the second term divided by the first term, which is negative 1/3 divided by 1, so my ratio is just negative 1/3. Now let's do my nth term formula. And this is the first term times the ratio raised to the n minus 1. And my first term is 1. My ratio is 1/3, n minus 1. So my nth term formula is 1/3 to the n minus 1. No, and it's actually negative 1/3. Keep the parentheses. You need to keep the parentheses for the whole thing. So we're going to set up our sigma. You always start at 1. Write your nth term formula down. And then what goes on top is how many terms you have, and I'm counting 5. And so this is where we stop.